This is Jill. I'm going to be talking about a presentation that I recently delivered at a conference, the National Business and Economic Society. The presentation is about data visualization, and I conducted it with an undergraduate student at UCCS, Shine Cho, and we did a survey of 162 managers and their visualization practices. Have a long history of using symbols and visualization to understand, record, and share information. Here's a very early example of cave drawings called Chamber of the Bulls. Here's another example, not quite as early, but this was from 1854, a visualization conducted by Dr. John Snow, who used the power of mapping to identify the source of a cholera outbreak in London. The map he created is based on the locations of deaths due to cholera, and this allowed him to see a clear pattern that no one had detected yet, and ultimately to determine the source of the outbreak. Visualization today can be much more complex than either of these examples, especially in the era of big data. However, it's also important to keep in mind that we still use a lot of very simple visualizations and symbols. Think, for example, road signs or even emojis to communicate complex emotions and other kinds of information. So why use visualizations? We've all heard the expression, a picture is worth 1,000 words. And while we probably should not interpret that literally, like many such expressions, there is some truth in it, partly evidenced by the common use or expression of the saying. This is one of my favorite quotes about visualization from a thought leader in the area, Edward Tufte. And he is professor emeritus at Yale and has conducted a lot of workshops on data visualization and written some beautiful illustrated books illustrating the principles. And he said, at their best, graphics are instruments for reasoning about quantitative information. So much like the Dr. John Snow cholera maps, what Tufte is trying to get at is that they're not only to communicate analysis after they're done, but also can help us actually figure out what is going on with the data. Another reason for using data visualization. Vision is how most people obtain most sensory information. It helps us to overcome the limits of working memory, which is about 5 plus or minus 2 items or factors. It allows for processing of multiple factors and dimensions at the same time, especially when we add in components like color, size, shape, or location or orientation. Another reason is for the aesthetics, the artistic appeal of it. Visualizations have been shown to increase the user or viewer's interest and engagement with the data. When to use visualization. Most people focus on using visualizations for communicating results of data that has been collected and analyzed. However, visualization can also be a powerful technique at other phases of the process. For example, during the planning phase, drawing out a plan or storyboarding techniques can be really useful here. And there are excellent articles documenting storyboarding process and its usefulness at organizations such as Pixar. Visualization helps us figure out in the planning phase what data we need, how and from whom and where can we obtain such data. And during the analysis phase, again, it can actually help us figure out and analyze what is going on with the data. And then, of course, communicating results. This is the stage most people focus on. Organizing our findings into visualizations that tell a coherent, meaningful story about our data. The purpose of the study, the current study that Shine and I conducted, was to understand whether and how managers actually use data visualization and what factors facilitate this use. Some additional questions we had were what tools and techniques are being used, for what purposes are managers using visualization, how are visualization knowledge and skills acquired, and also, do managers desire visualization training? As I mentioned previously, thought leaders in this area include Edward Tufte, Professor Emeritus at Yale, and he's done some work that most people would recognize outside of academics, work with companies like Apple, who are well known for their emphasis on design and making things user-friendly. Where does this research live? It's very interdisciplinary. So there's research conducted on visualization and data science. There's also research from sensation and perception, such as cognitive neuroscience. This would include things like how does the eye generally process and scan information? For example, in societies where we read from left to right, most people the eye starts at the top upper left of a visualization or graph and then zigzags down into Z patterns. There's a lot of research in pedagogy and training. For example, looking at whether visualizations can improve people's understanding of, of the data or information. And there's increasing interest from organizational scholars such as HR professionals. Guiding principles for data visualization, according to Tufte, include 1. Make large data sets coherent. 2. Encourage the eye to compare different pieces of data. 3. Reveal the data at multiple levels of detail so that you can go from broad concepts and categories into very specific aspects of the data. And last, but also quite important, is avoid distorting the truth. And there's some great examples of this from one of the chapters that was assigned in the previous module about how different kinds of displays can be very misleading. A framing model for our study was we wanted to look at what predicts individual visualization activities of managers. And we were predicting that there were 3 categories of factors: individual differences, so like personality, organizational culture, and also the characteristics of the job itself. For organizational culture, we asked, how does org culture impact individual visualization activities? And we used a scale with several items measuring data-driven culture, so how much an organization, that's part of the embedded way of life of using data and evidence-based management, and also an additional scale of big data visualization culture. Here are hypotheses that both of these cultural aspects would positively relate to, correlate with, or increase visualization activities. At the job level, we asked, how do job characteristics and requirements impact individual visualization activities? And we looked at information processing, problem solving, decision-making autonomy, and task significance. Some items here to show what people were actually asked and what makes up the different categories. So information processing would include things like, my job requires me to monitor a great deal of information. The job requires that I engage in a large amount of thinking. I have to keep track of more than one thing at a time. etc. For problem solving, this includes a job that would involve solving problems that have no obvious correct answer. The job requires me to be creative and requires me to deal with problems that I have not met before. Examples of decision-making autonomy means that the person has to make a lot of decisions on their own, and they have to use personal initiative or judgment in carrying out the work. And last, task significance. These are jobs where the decisions and the results of your work significantly affect the lives of other people. So our hypotheses were for all of these characteristics that they would be positively correlated with more individual visualization activities. For individual differences, here we were looking at personality and learning styles. We used the Big Five, and although we measured all five, our predictions were focused on openness to experience, which has to do with people who are interested in aesthetics, art, ideas, philosophy, and also conscientiousness. People high in conscientiousness are very goal-oriented, and so we thought that any tool that people can use to increase, their productivity or the quality of their work, that they would be more likely to do. For learning styles, there's visual, auditory, kinesthetic, and read-write. We measured all of them, but for probably self-explanatory reasons, we were predicting mostly that people who reported a visual learning preference would be more interested in doing visualization activities. So again, all of our hypotheses here were that these individual differences would positively relate to visualization. Our method, we surveyed 162 managers and supervisors who were recruited through Prolific. They were paid $5 to complete the survey. The sample was 47% male, mean age of 39.5 years, and standard deviation of 10.8. Sample characteristics, I have a chart here with the most common industries from which the managers came. So health, 31 of the 162 came from health, 22 education, 18 from government, 16 tech, and 12 from retail. Education of the sample, most had an associate's degree or higher. About a third, a little more than a third, had a bachelor's degree or a master's or doctorate. And here is an example of a type of visualization, a word cloud. And we put this together, created it based on the reported job titles, which was an open-ended question where the participants were asked to report what their job title was. Again, the measures that we used, we had a scale measuring data-driven culture, big data, visualization culture. We used the work design questionnaire published by Morgeson and Humphrey in 2006, very commonly used scale to measure different characteristics of a job. And the individual differences, we used the same scale that was used in the data that our class looked at earlier in the semester, the Big Five, and then we looked at VARC learning preferences. Our dependent variable was individual visualization activities. This was a scale that we created ourselves that included 8 items, such as how frequently people are using visualization, the number of tasks or responsibilities that they're using it for, and the number of tools like are you using Tableau and Power BI, or how many tools are you using? The reliability of our scale was decent, as was the confirmatory factor analysis. So we did do some confirmatory factor analyses to confirm the factor structure of the scales that we used. We also conducted Harmon's single factor test, which tests for common method variance, and we found that not to be a significant problem in our study, so that was good. We did descriptives, which I've already kind of reported some of those on for the sample characteristics, and we also conducted correlation and multiple regression. Results of the simple bivariate correlations, our first two hypotheses, that data-driven culture and big data visualization culture would be positively related to visualization activities, were supported with strong, fairly strong, moderate to strong correlations that were significant. Job characteristics, information processing and problem solving, those were significantly related to visualization activities. However, our other two hypotheses about decision-making autonomy and task significance were not supported. For the personality and learning preferences, openness to experience was positively related to visualization, but conscientiousness was not. And the visual learning preference was significantly related to visualization. Now, probably some of those variables relate to each other. So the next thing we did was enter all of those predictors into a multiple regression equation to predict visualization activities. And the results of that, a little hard to see on the slide, the R squared was 0.372, meaning that about 37% of the variance in visualization activities can be explained by these variables. And the variables that emerged as significant or remained as significant when all of the variables were entered, there was one at each level. So one was the big data visualization culture. The next was the information processing job requirements. And third was the personality variable of openness to experience. So those are the most important factors, at least the ones that we measured. We also did control for things, statistically control for things like organizational size, and that did not change the results. Some additional exploratory analyses. Most respondents reported that they were moderately or highly interested in visualization training. So these are numbers. So 48 said moderate interest, 42 high, and 34 very high. Additional exploratory analyses also related to interest in additional training. Interestingly, the more confident and familiar people already were with data visualization, and the more tools they were already using, that actually predict increased additional interest in more training. So the more they know, the more they want to know more. What visualization tools were being used? The most common was, and these are not mutually exclusive, so people could report, numerous things that they're using. The most common was Microsoft Office, like Excel. The next most common was by hand, pencil and paper. Then Power BI, Adobe Creative Cloud, followed by Google Data Studio and Tableau. We asked, how did you learn visualization skills? The most common was, and again, people could report multiple ways they were learning, but the most common was self-taught. So lots of people were saying, I learned from YouTube. The next most common was from colleagues. followed by online courses, and then least common was formal training or school. Limits and implications of our study. First, we had a relatively small sample size, and it was limited to managers in the UK and US. We had a cross-sectional, single method, single source design. We also noted that there are accessibility issues or concerns for people with vision impairment. Implications. We conclude that most managers do utilize data visualization in some form. The majority use simple, widely available tools like Microsoft Office or no special tools, just pencil and paper. Most managers desire additional visualization training, and we recommend more research is needed to address generalizability and also to establish best practices. Thanks for your time.